Determine whether the piecewise defined function is continuous at 2. So here we have fx is equal x squared when x less than 2, 5 when x is equal to minus x plus 6 if x greater than 2. We need to show that, or we need to determine if this function is continuous at 2 or discontinuous. So we need to check that the value of the function at x is equal to 2 is defined, and limit when x approach to 2 exists, and whether f2 is equal limit of fx when x approach to 2. So let us do it one by one. So we observe that f2 is defined and it is equal to 5. So the value of our function f at x is equal to is equal 5. So this function is defined. Then we need to see if the limit exists or not. So we need to take the limit of f when x approach to 2. Since this one we have piecewise function, so we need to approach to 2 from left, and we need to approach to 2 from right. So limit of fx when x approach to 2 from left, that's mean we need to take this function which is x squared. So it will be limit of fx squared, when x approach to 2 from left. Replacing x by 2, so we'll get 2 squared which is equal 4. The limit of fx when x approach to 2 from right. So for this one, we will take x greater than 2, which is this function minus x plus 6. So for minus x plus 6 limit, when x approach to 2 from right, this will be minus 2 plus 6, which is 4. Since the limit from left is equal to the limit from right, we conclude that the limit exists and it is equal 4. Then the last condition, we need to compare between the value of the function at x is equal to and the limit of the function when x approach to 2, and see if they are equal or not equal. So f2 is equal 5, limit of f when x approach to 2 is equal 4, so they are different. We conclude that this function is discontinuous since the limit of f when x approach to 2 is not equal to f2. So this function is discontinuous. في المثال هذا أول شيء بنشوف إيش قيمة الدالة عند 2. طبعا هو معطلنا إياها لأن هنا piecewise function. لما الأكس is equal to إذا قيمة الدالة تساوي 5. بعدين بنجيب الليمت، بنشوف بما إنه هنا عندي piecewise function لما الأكس less than 2 والأكس greater than 2، إذا نحن لازم ناخذ لما الأكس approach to 2 from right، لما الأكس approach to 2 from left. فلما الأكس approach to 2 from left بناخذ لما الأكس less than 2 اللي هي الفانكشن x squared. إذا بيصير عندي limit of x squared، نبدل الأكس بال2 بيصير عندي 4. بنفس الطريقة limit of x والأكس لما الأكس approach to 2 from right، إذا ناخذ x greater than 2 اللي هي الفانكشن minus x plus 6. بنعوض الماينس، بنعوض الأكس هنا ب2 بيصير عندي minus 2 plus 6 اللي هي 4. إذا الليمت من اليسار يساوي الليمت من اليمين يساوي 4. إذا نحن we conclude that limit of f لما الأكس approach to 2 is equal 4. آخر condition نحن لازم نتحقق هل قيمة الدالة لما الأكس تساوي 2 تساوي قيمة limit of the function لما الأكس approach to 2. لاحظ قيمة الدالة تساوي 5، قيمة الليمت تساوي 4. إذا هما مختلفين، إذا we conclude that this function is discontinuous. وعندنا هنا the graph of a function in example 2 which is the graph of this function. لاحظ إنه الليمت موجود ويساوي 4، قيمة الدالة تساوي 5. إذا نحن we conclude that this function is discontinuous. So this was about continuity at a point. Now we will talk about continuity on an interval. We will now extend the notation of continuity at a number a to continuity on an interval. يعني كنا متكلمين عن اللي هو الاتصال عند نقطة. الحين بننتقل لشيء ثاني اللي هو الاتصال في فترة، اللي هي فترة من إلى، اللي عندنا أحيانا فترة مغلقة وأحيانا فترة مفتوحة على حسب. So this will be in definition 232. Continuity on an interval. A function f is continuous on an open interval a to b if it is continuous at every number in the interval, and on a closed interval a to b if it is continuous on the open interval a to b, and in addition limit of fx لما x approach to a from right is equal fa and limit of fx when x approach to b from left is equal fb. So in the open interval, we conclude this function is continuous in the open interval a to b if it is continuous at every number in that interval. For example, if we take the interval from 1 to 5. So this function is continuous on the open interval 1 to 5 if it is continuous at 2, if it is continuous at 3, if it is continuous at 4. And what the continuity in the closed interval, we said that this function is continuous on a closed interval if it is continuous on an open interval. In addition, also limit of f لما x approach to a from right is equal fa, limit of f لما x approach to b from left is equal fb. For example, if we have also the same interval 1 to 5, but here it is closed. So this function is continuous from 1 to 5 if it is continuous at 2, 3, 4, and also limit of f when x approach to 1 from right is equal f1, and limit of f when x approach to 5 from left is equal f5. يعني هنا عندنا يتكلم عن الاتصال في فترة. طبعا عندنا نوع من الفترات، فترة مفتوحة وفترة مغلقة. فبنقول إنه الفانكشن متصلة في الفترة المفتوحة إذا كانت متصلة عند كل رقم موجود داخل هذه الفترة. فمثلا لو أخذنا الفترة من 1 إلى 5 اللي هي open interval، فبنقول إنه الفانكشن هذه متصلة إذا كانت متصلة عند كل نمبر موجود داخل هذه الفترة. إذا كانت متصلة عند 2، متصلة عند 3، متصلة عند 4. طبعا أنا هنا خذيت بس اللي هي الأعداد الصحيحة، بس هي اللي هي كل عدد موجود داخل هذه الفترة. طيب in a closed interval لو كانت نفس الفترة اللي هي from 1 to 5، إذا لازم تكون الفانكشن متصلة مثلا لازم تكون متصلة عند 2، 3، 4. بالإضافة إلى إنه limit of f لما الx approach to 1 from right لازم يساوي f1، والlimit of f لما الx approach to 5 from left لازم تساوي f5. إذا متصلة في الأوبن انترفال إذا كانت متصلة عند كل نقطة موجودة داخل الانترفال، متصلة في الكلوز الانترفال إذا كانت متصلة عند كل نقطة موجودة داخل الانترفال، بالإضافة إلى إنه limit of f لما الx approach to a from right is equal fa، limit of f لما الx approach to b from left is equal fb. So here we have example 3. Determine intervals in which the following functions are continuous on. So here we have 3 functions. We need to know in which interval these functions are continuous. طبعا دايما لما يسألنا عن ال continuity of the function هو كأنه يسأل عن الدومين، فنحاول نجيب الدومين لكي. So here we have a 1 over root of 1 minus x squared. We need to know the intervals in which this function is continuous. So root of 1 minus x squared is in the denominator, so it should be not equal to 0. And since here we have root, so we'll take what is under the root and put it greater than 0. So we'll take 1 minus x squared is greater than 0. That's mean x squared less than 1, so x should be between minus 1 and 1. So the interval in which our function is continuous will be in the open interval minus 1 to 1. But why we don't take the closed interval? Because if you take the closed interval, this will, if you substitute here f1, it will be 1 over root 1 minus 1, which is 1 over 0, which does not exist. Similarly, f minus 1 will be 1 over root 1 minus 1 square, so it will be 1 minus 1, 0, 1 over 0 does not exist. So that's why we need to take it just in the open interval, which is from minus 1 to 1. And here we have the graph of our function 1 over root of 1 minus x squared. It is continuous in the closed interval minus 1 to in the open interval minus 1 to 1. يعني هنا عندنا الدالة 1 over root 1 minus x squared. بما أنه عندنا root of 1 minus x squared موجودة في المقام، إذا نحن ناخذ إيش موجود تحت الجذر، لكن بشرط يكون أكبر من الصفر بدون مساواة، لأنه لو في مساواة بيطلع لنا الناتج اللي هي 1 over 0 does not exist. فبناخذ 1 minus x squared greater than 0، إذا معناتها ال x squared أقل من سوري 1 minus x squared أيوة greater than 0. إذا الx squared أقل من الواحد، إذا الx محصورة ما بين السالب واحد والواحد. طبعا ما أخذنا اللي هي الكلوزد انترفال. ليش؟ لأنه لو أخذنا closed interval إذا معناته لما نجي نحسب f سالب 1 f minus 1 يطلع الناتج does not exist. لما نجي نحسب f ال1 نفس الشيء يطلع لنا does not exist، إذا معناتها ما continuous. أساس كذا أخذنا الانترفال اللي هي open. وطبعا لما نجي نشوف الرسمة نلاحظ it is continuous in the interval from -1 to 1. Then we have b, root of 1 minus x squared. So this function is in the numerator. So just we need to take 1 minus x squared greater than or equal to 0. So 1 minus x squared greater than or equal to 0, that's mean x squared less than 1. So x should be between -1 and 1. But observe that here we have -1 and 1 is a closed interval, because we can find f1 which is equal to 0, f minus 1 also will be equal to 0. But also we need to check that since it is a closed interval, we need to check if the limit of f when x approach to -1 from right, is it equal to f minus 1? And limit of f when x approach to 1 from left, is it equal to f1? So here we have a limit of x when x approach to -1 from right. So here we have the graph approach to -1 from right, the value of the limit is equal to 0. And f minus 1 is equal to 0, so they are equal. Similarly, limit of f when x approach to 1 from left, so we approach to 1 from left, the value of the function is equal it is equal to 0, and f1 is equal to 0, so they are equal. We conclude this function is continuous in the closed interval -1 to 1. يعني هنا عندنا الفانكشن root of 1 minus x squared. طبعا هذه بما أنها الفانكشن موجودة في البسط، إذا نحن نقدر نأخذ اللي موجود تحت الجذر أكبر من أو يساوي، لأن هنا عادي تحت الجذر يكون 0. طبعا لما نجي نحل 1 minus x squared greater than or equal to 0، إذا معناتها ال x squared أقل من الواحد، أقل من أو تساوي الواحد، إذا ال x between -1 و ال1. هنا closed interval لأنه عادي قد يصير -1 و ال1. طبعا ما يكفي إن نحن ناخذ بس اللي هو الدومين فقط، لازم نتأكد إنه الليمت لما الإكس approach to -1 من الرايت يساوي f minus 1، والليمت لما الإكس approach to 1 from left is equal f1. من الرسمة they are equal, so we conclude this function is continuous on the closed interval -1 to 1. Then the last example we have fx is equal root of x minus 1. And we will do it in the same way what we did in part B. So this one will take x minus 1 greater than or equal to 0, that's mean x greater than or equal 1. So this function is continuous on the unbounded interval from 1 to infinity. And because we take the closed interval, we need to check if limit of f when x approach to 1 from right, is it equal to f1? Here we have this graph, limit when x approach to 1 from right, it is equal to 0. And f1 is equal to 0, so they are equal. We conclude this function is continuous on the closed interval 1 to infinity. يعني هنا عندنا اللي هي الفانكشن root of x minus 1 موجودة في البسط. إذا ناخذ اللي موجود تحت الأساس نجيب الدومين أو الفترة للاتصال، ناخذ إيش موجود تحت الجذر ونخليه أكبر من أو يساوي الصفر. لاحظ x minus 1 greater than or equal to 0، إذا معناتها الx أكبر من أو تساوي الواحد. إذا الإكس بناخذها من 1 to infinity. طبعا ما يكفي نحن نقول إنها يعني ناخذ الدومين فقط، لازم نتأكد هل الليمت لما الإكس approach to 1 من الرايت يساوي الإف 1 من خلال الرسمة they are equal وتساوي 0. بما أنه هنا الإنفينيتي open interval، إذا نحن ما يحتاج نجيب الليمت لما الإكس approach to infinity من الليفت ونقول هل تساوي إف infinity، لأنه هنا الفترة مفتوحة. عند الإنفينيتي دائما نخلي الفترة مفتوحة. فأساس كده الفانكشن this one is continuous in the closed interval 1 to infinity. Then we have theorem 231, continuity of a sum, product and quotient. So if the function f and g are continuous at a number a, then the sum f plus g, the product fg, and the quotient f over g where g is not equal to 0 are continuous at x is equal a. So if f continuous, g continuous, then f plus g will be continuous, fg will be continuous, and f over g where g is not equal to 0 will be also continuous at a. يعني إذا عندنا الفانكشن f continuous عند ال a، ال g continuous عند ال a، إذا لما أريد أجمع ال f زائد ال g بتكون continuous عند ال a. نفس الشيء f مضروبة في ال g will be continuous عند ال a. f over g will be continuous provided that إنه الجي ما تساوي 0.